Coming up next on the History Channel, kidney disease and how it all began.
Interesting, okay.
In current times, doctors understand that protein leakage in urine, known as albumin, is a key indicator of declining kidney function. But this wasn't always the case. In fact, it started long ago with Hippocrates, the father of modern medicine, who was the first to note that foamy urine meant that death was close at hand, though at the time it wasn't fully understood why. Sit back while we explore the history of kidney disease.
Hippocrates may have been one of the first to note that foamy urine meant that the body was failing, but most of the significant discovery for kidney health didn't come until 2,000 years later. This first era of kidney health is known as the discovery of albumin and urea. In 1622, Jean Baptiste, and not Delacroix, no, this is von Helmont, who was a noted physician and chemist. Jean was the first to note a unique salt in the urine, and he boiled urine to attempt to purify and determine what this unique salt was. However, the process was only slightly successful and didn't lead to much discovery. In fact, it was more successful in laying foundational groundwork for Mr. Hermann Boerhaave, who in the early 1700s determined a better way to purify and analyze urine. And this led to the discovery of the substance we now call urea, but at the time it was known as a native salt of urine. In fact, his process took 1 to 2 years to purify and examine. He described what he found as an element of which only a living being could possess. And this was a reflection of the philosophy at the time known as vitalism. Vitalism is and was a belief based on the spirit or special force of a living thing, which had existed since ancient Egypt, really. This special force was thought of as a vital and unique to only living things and would help develop the being and direct emotions and actions of that being. In 1765, Domenico was the first to notice that dropsical patients, this is known as edema today, was due from swelling from extra fluid. In fact, he also discovered albumin through coagulated urine of the patient. In 1773, Hilary Roulet analyzed something he called a soapy matter. This was evaporated into a somewhat urea molecule, still very impure at the time. 1776 saw Carl doing experiments to try and understand how bladder stones were formed. And he was able to isolate an acid substance, which we now know as uric acid. Some of you on dialysis might know uric acid because it's what causes gout. In 1790, French chemists during the French Revolution worked to try and understand this soapy matter first described by Hilary. Though they did further advance the understanding they had at the time, it's not until Cruikshank he is credited with the full discovery of what soapy matter was. And this is in 1798 when Cruikshank was able to produce a crystalline urea substance. He also noted that only certain dropsical patients were able to have coagulated urine for some reason. One at the time was known for liver disease, while something was still being discovered. In 1799, Fourcroy and his associate, Vauquelin, formed almost the purest form of urea we know today. They also coined the term urea, meaning from urine. In 1803, Joseph Comhier experimented on dogs. His experiments were to demonstrate that urea would increase if a kidney was removed or if someone were to have a damaged kidney. And this was the beginning of understanding that urine is actually produced from the kidney. In 1808, Fourcroy and his associate come back to experiment in the process again for a more pure molecule of urea. And this enables them to further understand how bladder stones are actually formed. And by 1817, several scientists around the world, but most notably William Prout, is credited with formulating, analyzing, and describing the function of the urea molecule. He was also the first open scientist to voice his opposition against the theory of vitalism at the time. He suggested that from the chemical composition of his urea molecule, that it could be synthesized outside of a living being, and thus would end the theory of vitalism. However, his attempt to prove and synthesize a molecule of urea failed at the time. In 1820, Richard Bright would be the first physician to notice that a collection of symptoms or signs, that being edema and albumin mainly, were related to kidney health and kidney problems. He's dubbed the father of nephrology. In fact, kidney disease was first called Bright's disease, which leads us to our next significant era, Bright's disease. Or is it? In 1828, Frederick challenged the opinions of previous chemists of the time and succeeded where William Prout could not, killing vitalism. Well, that is to say, synthetically produce a urea molecule anyway. 1836, Bright makes another important discovery, cardiac hypertrophy. He hypothesized that altered blood status, such as high levels of urea, increase the work that needs to be done by the heart, thus making the heart bigger. When muscles work more, they get larger. But it wouldn't be until the 1850s and the implementation of microscope techniques that he would be proven correct. In 1842, William Bowman makes the next biggest contribution to the field of nephrology, that is, things related to the kidney. He was able to examine and describe the structure and function of the glomerulus. In fact, the protected shell around the glomerulus was known as the Bowman's capsule, even until today's time. In 1850, the first person noted to be diagnosed with Bright's disease. And in 1856, J. Picard, okay, not that Picard, this Picard. Okay, well, J. Picard improved the method to which we could measure urea, which became the standard for the 1900s. In the mid-50s, Frederick began to lay the foundational steps of understanding glomerular filtration. You might know this as glomerular filtration rate, GFR, which one of your lab work. Hydrostatic pressure, and also pore size of the Bowman's capsule. And how when these are changed, it actually induces Bright's disease, or in today's term, it causes kidney disease. The late 50s also saw the theory of dialysis by Graham. After demonstrating the purpose and effectiveness, Graham and Bright worked together to produce a process to help with Bright's disease. Though they continued to experiment with the process, Bright is on record saying it could take up to 50 years from that point to actually produce something that could help someone. By 1860s, physicians started to wonder if Bright's disease was one disease or many. In Paris, 3 causes were found: acute nephritis, nephrotic syndrome, and paleonephritis, which is a type of kidney disease caused by a UTI bacterial infection. England saw 2 types, one with edema and large kidneys, and one without edema and shrunken or contracted kidneys. However, Germany proposed a unitary theory to that, and proposed that these were the same diseases, just at different points in time. Jacob Henle, in 1860, laid the next foundational groundwork for kidney understanding with the nephron tubules, to which he's credited the loop of Henle. This was a significant breakthrough in not only understanding how urine is produced, but also in the future would help clinicians and scientists understand how to make diuretics. Adolf Fick in 1870 was the first to calculate a GFR using urea excretion. At this time, Edwin is also noted to discover a new form of nephritis or Bright's disease, which he called glomerulonephritis, what I was actually diagnosed with many years ago. Before the turn of the century, in 1893, a new invention, the sphygmometer, blood pressure machine. the new advancement in blood pressure machine became available. And this allowed us to discover latent atherosclerosis, which would become more of a factor by 1920, which is when it became more widely accepted as essential hypertension. The early 1900s saw scientists trying to discover the difference between edematous waste, which is patients who have edema who can still urinate, and the excretion of urea. Within the decade, this eventually leads the scientists to determine that edema was actually caused to the retention of sodium in a patient and not urea. In 1920, Thomas Addis, a famous scientist and physician of the time, began the quantitative analysis of red and white blood cells along with CAST that is found in blood serum. And this was widely known as the Addis count. In 1935, Giovanni Ferrero experiments and discovers creatinine's relationship to the kidney. He is the first to advocate for a new test, a creatinine clearance test, to test the function of a kidney. By 1940, Thomas Addis and Giovanni worked together to first implement this creatinine clearance test to be a standard test. And the end to this first half of kidney history takes place in 1945 with Robert Pitts, who was the first to study phosphorus and its relation to the kidney. All right, y'all, that's going to be it for this video, but I will be making a part 2, and in that I'm going to be, covering the more modern history of kidneys. So be on the lookout for that, and until next time, warriors.